Hello, everybody. So yeah, today, so the topic of our presentation today is investigation of driving behavior at alternative intersection designs and safety improvement. So this is a driving simulator experiment being conducted in University of Central Florida. Can you see my screen, everybody? Can you hear me?
Yes.
Okay. Okay. So the outlines of this presentation is introduction, then brief about the alternative intersection designs and experiment design, experiment development, analysis methodology, results, and at the end in conclusions and recommendations. Okay, so several intersection designs have been proposed as alternative to the four-leg conventional intersection design in order to improve traffic safety and operation at intersection. The effectiveness of alternative intersection designs comes from the reconfiguration of some movement patterns, mainly the left turn movement, and prevention of conducting some movement directly at the main intersection by allowing to perform them upstream or downstream of the main intersection reduces the number of traffic conflict points between movements, which result in two main advantages. So the first advantage is that a low number of conflict points reduces the interaction between vehicles, which is an indication of a safer traffic condition. And the second benefit is reducing the average control delay at the intersection, since alternative intersections provide two-phase signalization at the whole intersection. However, the evaluation of alternative intersection designs indicated that enhancing traffic safety and operation simultaneously at the intersection has not been achieved at most of alternative intersection designs. Some of them have more safety benefits than operational benefits. In contrast, some other alternative intersection designs have more effectiveness in enhancing traffic operation than reducing the crash frequency. Only few designs which have a very low number of conflict points have the efficiency to improve both. I mean here the traffic safety and operation at the intersections, but also only under certain traffic conditions. Okay, so the restricted crossing U-turn RCUT intersection has 14 conflict points, which is the lowest number of traffic conflict points at alternative intersection design. As a result, many studies have found that the RCUT intersection has safety benefits represented by reducing the number and the severity of crashes. Besides this, low value of average control delay and high throughput values were recorded at the RCUT intersection due to reducing the number of signal phases from 4 at the conventional signalized intersection to 2 signal phases. However, its operation enhancement is manifested only under unbalanced traffic conditions. And the shifting movement in intersection SM design, which have been recently introduced by Al-Omari and Abdelati to replace the RCUT intersection implementation under moderate to heavy minor traffic volumes, was found that it is significantly outperforms the RCUT intersection design in terms of traffic operation. And sometimes it has like a less intersection average control delay by 60% in comparison with the RCUT. So they recommend to use this intersection design under moderate and heavy minor traffic volumes. The low number of conflict points at the SM intersection design, which is 14 conflict points, like the number of conflict points at the RCUT intersection, is an indication of a safe traffic operation. However, unconventional movement patterns may confuse drivers. For further investigation of the safety aspects of the SM intersection design, a driving simulation experiment was conducted in this study in order to evaluate the traffic safety at the SM intersection design and to determine the extent of confusion that drivers could have while crossing this intersection design. This is in comparison with conventional and RCUT signalized intersections. Furthermore, an evaluation of the effect of implementing the infrastructure to vehicle communication on driving behavior and traffic safety improvement at unconventional intersection was also accomplished in this study. So the alternative intersection designs that considered in this study, the first one is the RCUT intersection. RCUT and also the SM intersection, they were considered for analysis in this study because they own the lowest number of conflict points among other alternative intersections. Both RCUT and SM intersections provide a two-phase signalization. The RCUT intersection consists of main intersection and two median U-turn crossovers upstream and downstream of the main intersection. At the RCUT intersection, all movements from the major road are done as usual. I mean here as at the conventional intersection. The minor through right turn movement is also done as usual at the RCUT intersection, while the minor through and left turn movements are performed by turning right at the main intersection and then make a U-turn at the median U-turn crossover, and by turning right at the main intersection, the minor through movement is done. These are the traffic movement patterns from the minor road at the RCUT intersection. So the SM intersection has three sub-intersections: the central area and the upstream or downstream intersection. So if this is the upstream, this will be the downstream or the opposite. And the side street of the SM intersection is provided as a service road for minor traffic and major left turn traffic. I will describe this later. So at the SM intersection, all movements from the major road are done as they are at the conventional intersection, except the left turn movement. Major left turn traffic accesses the side street in the central area and combines with the minor traffic. The combined traffic, I mean here the minor and the major left turn traffic, heads to the upstream or the downstream intersection, where it accesses the major road by turning left, and by turning right at the central area, the major left turn movement is accomplished. These are the traffic movement patterns from the major road at the SM intersection. Minor road traffic at the SM intersection must turn right to access the side street in the central area. The combined traffic, again here, I mean here the minor traffic and the major left turn traffic, heads to the upstream or the downstream intersection, where it accesses also the major road by turning left, except the minor right turn movement, which is done by turning right at the upstream or the downstream intersection, and then by turning by turning right at the central area, the minor through movement is accomplished. Okay, so the experimental design or experiment design. So firstly, the geometric design of these intersections. Unconventional intersection designs which were considered in this study, I mean here the RCUT and the SM intersection, were simulated along with the conventional intersection in the daytime in an urban environment where a divided 6-lane arterial intersect with a divided 4-lane collector. Consistent lane configuration and crossover spacing were considered. A 0.8 miles straight undivided 4-lane road connects every 2 intersections. All roads in the simulated roadway network have 12 feet in width lanes. All intersections have been controlled by traffic signals. Lane marking has been implemented at the intersection to specify the permitted movement or movements that can be done by using any lane. So for the signage, so different regulatory and guide signs were used in this experiment, especially at the at intersections. So this figure uh, shows the signs that use at the conventional intersection, and these are the signs that were used at the RCUT intersection, and these are the signs that were used at the SM intersection. So design of scenarios. Two experiments have been conducted in this study. The first one was to investigate the driving behavior at unconventional intersection designs and to evaluate the safety aspects of the SM intersection. The second experiment was to evaluate the effectiveness of using infrastructure to vehicle communication. Both experiments are full factorial design experiments with one within subject factor. The factor in the first experiment was intersection type, which with three levels, which are the intersection types here is conventional, RCUT, and SM intersection. All participants were requested to drive and accomplish four movements at the three intersection designs. These four movements that are covering all unconventional movements at RCUT and SM intersections are the minor road movements in addition to the major left turn movement. In the second experiment, the factor was the use of I2V communication at unconventional intersections with two levels. Also, use it or not. All participants were requested to accomplish all the unconventional movements at RCUT and SM intersections with and without using I2V communication. The I2V communication was simulated by sending navigation information for guiding drivers to accomplish the unconventional movements. Visual and voice messages were sent to drivers before every stage of each unconventional movement at RCUT and SM intersections. For example, these are the visual information provided while performing the minor throw movement at the RCUT intersection. We have three stages like for this movement, and before every stage, these are the visual information that were sent to the driver. Scenario, yeah, we're still in design of scenario. So there was 10 minutes into like the time is 10, or the duration of these routes is 10 minutes. So 10 minutes routes were designed to perform right turn, through, and left turn movements at a combination of conventional RCUT and SM intersections. Light traffic was set in the roadway environment, and the I2V communication was only implemented in one route. I name it within I2V route, while other routes without I2V routes are without using the I2V communication. The driver was directed to do the four movements. Here the right turn, through, and left turn from the minor road, and the left turn movement from the major road at the three intersection types, which they are the conventional, RCUT, SM intersections, in the two without I2V routes, while the driver was asked to perform only the unconventional movements at the RCUT and the SM intersections in the within I2V route, knowing that there is like a conventional intersection in this route, but as a control intersections. To give the driver time to engage, the driver time to engage in driving before considering the data for analysis, the driver was directed in all routes to do a through movement at conventional intersection where the data of this movement was not accounted in the analysis. A spacing of 0.8 mile between intersections was provided to give the driver enough time to go back to normal driving behavior before reaching the next intersection. All traffic signals were triggered to have a green light once the driver is at 800 feet from the intersection, except the first and the fourth, the fifth, or the sixth intersections, which have red traffic signals to avoid expectation of a green light at every intersection in the route. Data at intersection with red traffic signals were excluded from the analysis. The driver is asked to head in a specific direction at every intersection by sending text and voice messages um, at 1,100 feet upstream of the first stop line at the intersection. Experiment development. So the data in this study was obtained from 32 participants who had completed the experiment. Upon the participant reaching the lab, she or he was briefed about the driving simulator and the experiment. The participant also learned about the unconventional intersections, especially the RCUT and the SM. In the beginning, the participant was subjected to trafficless practice route. So the main advantage of this to practice the driver with the with the vehicle itself. I mean here the driving simulator, and he asked to increase the speed, stop the car or the vehicle, and make some turning movements. The order of the intersections within the route and the order of the within I2V and without I2V routes and the order of without I2V routes themselves were changed to mitigate the order effect. Analysis methodology. Four surrogate safety measures were considered the performance measures in this study. The relative area of speeding, the relative area of sudden acceleration, the relative area of sudden brake, and then deviation. So with the definition of the first surrogate safety measures is the relative area of speeding. This is the normalized relative area per unit time bounded between the speed profile and the speed limit line, where speed is above the speed limit. This is, this is the definition for the second and the third also measures, but the threshold here is not the speed limit, is 6.6 feet per second square for the sudden acceleration and sudden brake. And the lane deviation is the standard deviation of the vehicle position within the lane. The one-way repeated measures analysis of variance and the per-t-test were employed for testing whether values of the surrogate safety measures at the three intersection types and within and without using I2V communication are significantly different. Results. Most participants have accomplished the minor road movements at the three intersection types and major left turn movement at conventional and RCUT intersection. However, about half of participants only have accomplished the major left turn at the SM intersection. The results indicated that significantly lower speeding values were recorded while performing the minor right turn movement at the SM intersection in comparison with conventional and RCUT intersections. While there was no significant difference in speeding behavior of this movement at conventional and RCUT intersection, minor throw and left turn movements at the conventional intersection are performed with significantly higher speeding values than RCUT and SM intersections. There was no significant difference in speeding behavior of the minor throw movement at RCUT and SM intersections, while drivers drive with significantly more speeding during performing the minor left turn movement at the SM intersection in comparison with the RCUT and with the RCUT intersection. It was found that speeding behavior while performing the major left turn movement at the three intersection types is similar without significant difference. The minor throw movement at the conventional intersection is accomplished without sudden acceleration and sudden brake as significantly opposite to acceleration and brake behaviors at RCUT and SM intersections, where sudden acceleration and sudden brake behaviors were recorded. Similar sudden acceleration and sudden brake behaviors were recorded at or were noticed at RCUT and SM intersections. On the other hand, there was no significant differences between sudden acceleration and sudden brake values of the other movements at the three intersection types except sudden acceleration values of the major left turn movement. The result shows that that this movement is performed at the conventional intersection with significantly lower sudden acceleration value in comparison to the value at the SM intersection. The lane deviation of the minor right turn and major left turn movement at the three intersection times were not significantly different. In contrast, the minor through movement at the conventional intersection is performed with significantly lower lane deviation values than at RCUT and SM intersections, while there was no significant difference in the lane deviation of this movement at RCUT and SM intersection. On the other hand, the lane deviation of the minor left turn movement at the SM intersection is significantly lower than at conventional and RCUT intersections without a significant difference in the lane deviation values of this movement at conventional and RCUT intersections. So evaluation the effectiveness of I2V communication. The first approach for this evaluation is its role in helping driver to understand and accomplish the desired movement. The RCUT test indicated that there is no association between using I2V communication and performing the unconventional movements at RCUT and SM intersections, despite that there was a notable increase in the number of participants um, who performed the major left turn movement at the SM intersection by using the I2V communication. So without I2V 14 and with I2V, with using the I2V communication, 29 participants have accomplished this movement. By using I2V communication, most drivers have done the major left turn movement at the SM intersection. The number of drivers that accomplished this movement was doubled in the I2V communication environment. Most of participants have found that providing I2V communication during performing the unconventional movements either is helpful or very helpful. It was found that speeding, sudden acceleration, sudden brake, and lane deviation behaviors with and without using I2V communication are very similar, and there were no significant difference except very few cases. So the conclusion and recommendation of this study, so RCUT and SM intersections have similar safety effectiveness, and they are safer than at the conventional intersection due to the low speeding values. The evaluation of using I2V communication indicated that it's effective in guiding drivers to perform the unconventional movements and improving drivers' awareness regarding the major left turn movement at the SM intersection must be achieved by educating drivers through the different media sources, and also different signs configuration must be like testing different signs of configuration must be achieved also in future research to improve the driving behavior at the SM intersection, especially when he or she like perform the major left turn movement at the SM intersection. And thank you very much for your attendance and listening.